Let's talk about that feeling. You just finished your Docker build, you run Docker images, and your jaw drops. The image is huge. We have all been there. But what if I told you that massive size isn't just unnecessary, it's actually easy to fix? And look, that's not some wild exaggeration. This is a super common scenario for anyone using that traditional single-stage Docker build. And it's a problem that we're going to solve right here, right now. So, what is actually causing all this bloat? Well, the main culprit is usually the way we first learn to write a Docker file, the single-stage build. Let's really unpack what that means. Think about a standard Docker file. Every single line, every command, it adds a new layer. You start with a base image, then you install your build tools, you download dependencies, you copy your source code, you compile everything, and all of it, every single tool and intermediate file gets permanently baked into that final image. This slide just nails the core problem, right? We end up mixing up what we need to build the app with what we need to run the app. On the left, you've got the entire factory, the SDKs, the compilers, all the raw materials. But on the right, that's what we actually need to ship to our users, just the finished application and only its most essential runtime libraries. Everything else is just dead weight. Okay, so the image is big. So what? Who cares? Well, in a real production environment, that dead weight has some very real and very painful consequences. Take a look at this. 880 megabytes. That's the size of a Docker image for a super simple Hello World Java app built the old way. Nearly a gigabyte for Hello World. Just imagine what this looks like for a real complex application. And this size problem isn't just about disk space. It slows down your entire development workflow. Pushing and pulling these enormous images from a container registry takes forever. That means your CI/CD pipelines get slower. Your cloud storage costs go up, and maybe most importantly, you're massively increasing your security attack surface. More stuff in the image means more potential vulnerabilities. Seriously, just pause and think about that for a second. The container that's running your live application, serving actual customers, it probably has compilers and build tools sitting inside it that it will never, ever use again. It's just inefficient, and it's a security risk we don't need to take. Okay, so enough about the problem. Thankfully, there is a much, much better way. Docker introduced this incredibly powerful feature designed to solve this exact problem, the multi-stage build. And it is such an elegant solution to all this bloat. You know, the core idea is actually brilliantly simple. Inside one single Docker file, you just use more than one from statement. Each from kicks off a brand new, separate, temporary build environment. So you can do all your heavy lifting, all the compiling and dependency downloading in an early stage. And then you just selectively copy only the final essential files into a squeaky clean final stage. Let's actually walk through this Go example. First, see how we define a stage and name it builder? We're using the full Golang image here to compile our app. That creates our final binary. Then, and this is the key, we start a totally fresh stage with from scratch, which is literally an empty image. And here's the magic trick. That copy/from equals builder command, it reaches back into that first stage and pulls only the compiled binary into our new clean stage. The SDK, the source code, all that stuff from the builder stage, it just gets thrown away. Gone. So what's the actual payoff here? Is it worth the effort? Let's go back to that Java Hello World app and see what happens when we switch to a multi-stage build. And there it is. The proof is right there. The original single-stage image was that bloated 880 megabytes. But by separating our build from our runtime, the new multi-stage image is only 428 megabytes. We literally cut the size in half just by restructuring our Docker file. That is a 51% reduction for the exact same application with the exact same functionality. We didn't change a single line of our app's code. We just built it smarter. And for our compiled languages like Go that spit out these nice self-contained static binaries, the results can be even more insane. We've seen real-world examples where a 1 gigabyte development image shrinks down to a final production image of just 16 megabytes, a 98% reduction. That completely changes the game for how fast you can deploy. Okay, now that you can see how powerful this is, let's cover a few pro tips to make your multi-stage builds even more lean and secure for a real production environment. All right, first up, for your final runtime stage, always use the smallest base image you can get away with. An Alpine image is great. Scratch is even better if you have a static binary. And for top-tier security, check out Google's distroless images. They have literally nothing in them but your app and its dependencies. Second, you have to use a Docker ignore file. This stops things like your .get folder or local build files from ever getting into the build context in the first place. And finally, please pin your base image versions. Using something like Node 14 Alpine is way more predictable and secure than just grabbing Node latest. All right, I know that was a lot, but this is such a critical concept for anyone working with containers today. Let's just quickly recap the most important takeaways. So let's boil it all down. The problem? Single-stage builds are bloated with build tools, which slows you down and increases security risks. The solution? Multi-stage builds, which let you separate your build environment from your runtime environment all in one file. The result? You get drastically smaller, faster, and more secure container images that are truly production-ready. So now you know how to make your final images way smaller. But what about making the build process itself lightning fast? Well, in our next explainer, we're going to dive deep into unlocking build speed with Docker layer caching. It's really the other half of the optimization puzzle. Make sure you're subscribed so you don't miss it. Thanks for watching.